Day 4 and day 5, we are getting right to it, okay? So day 4 is all about margin of error and confidence intervals, okay? Keep it short and sweet. So margin of error, this is going to be the interval that we are a certain percent confident that we are within from an estimated statistic, okay? Basically all that means is we're going to have plus or minus a digit, okay? And this is just leaving room for error in studies. So basically anytime that we do a study, that we're collecting data, whatever, we're humans, right? Okay, so we have to leave room in there for what we call error, okay? Just things that could happen. This is used a lot. It's used in sports, it's used in weather, it's used in just about everything, okay? Any type of data experiment that you do, you leave room for error, okay? For instance, right now I'm in grad school and taking a class about IQ testing. IQ testing, we use a margin of error, okay? We know that if I'm giving an IQ test to somebody, there's a certain percent I have to account for that I could be wrong, okay? And then we have what we call confidence intervals. So basically this is just using that margin of error, but adding it to whatever statistic that we're using, okay? And this is going to be written as, in parentheses, a low bound, comma, high bound, okay? So lowest to highest. And once again, we find this using the margin of error. So lots of words there. Let me just make it make sense here. So we're going to start with example 1. We got a sample mean of 43. What's a mean? Average, okay? Just an average of 43, and it's saying that the margin of error is a plus or minus 6. It's asking me for the confidence interval, okay? So here's how I do this. 43 minus 6 equals what? 37. 43 plus 6 equals, what'd you say? 49. There we have it. 37 is my low bound, 49 is my upper bound. That's my answer. That's my confidence interval. So if my margin of error is 6, subtract 6 to get my low bound, and then I add 6 to my mean to get my high bound. Does that make sense? Okay. Same thing with, what if we have to go backwards, okay? What if I give you the confidence interval, 82 to 94, and I ask you to find the sample mean, so the average, and the margin of error, okay? How do I find the average of two numbers? Yeah, okay, so we'd add these up and then divide by how many there are, which in this case is just 2. So what is 82 plus 94? What's 82 plus 94? Get a calculator out. Come on, come on. 176. Okay. Divide that by 2. 88. There we have it. Okay. That is what we call the mean, which is sometimes used the notation x bar. Okay. The other notation we might use is a Greek letter mu, which we'll see on the next page. Or you could literally just write sample mean if you don't want to get into notations right now. You'll really only use these notations if you go on to take another stats class after this one, okay? So 88 is my mean or my average, okay? But it's still asking me for one more thing. It's asking me for the margin of error, okay? So if I know that my confidence interval is 82 to 94 and the mean is 88, what do you think the margin of error would be? Go back up to number 1. 6? Okay. Yeah, so you can find that one of two ways, okay? You could take your mean and subtract your low bound. That gives you 6, okay? You could take your high bound and subtract your mean. That gives you 6, okay? So either way, we just know that 88 is the average of those two numbers. So in that case, since it's two numbers, it's going to be the middle of them, okay? I would subtract 6 from 88 to get 82. I would add 6 to 88 to get 94. Does that make sense? So plus or minus 6 is what I need to see for your margin of error. So sample mean is 88. Plus or minus 6 is my margin of error. Does that make sense? We all see how we got that? Just going backwards. Okay? All right. I want you to go do 2 and 4. Okay? 2 is like number 1 and 4 is like number 3. So give you a couple minutes, get those done, work with the people around you if you want to. Okay, number 2. So a data set has a sample mean of 67 and the margin of error is plus or minus 4.3. What would be the confidence interval? 62.7, 71.3, Noah tells me. We agree with that? Okay, cool. So we found that by taking that 67, subtracting 4.3, and then taking 67 and adding 4.3, correct? Okay, and then number 4 gives me the confidence interval, 43 to 72, and it's asking me to find the sample mean and the margin of error. What do we think? What do we start with?
Yeah, 43 and 72.
Okay.
115.
That equals 115.
Yeah, and then you divide it by 2.
Which is
57.5.
okay. So that is my
Sample.
mean. We'll just write it out. 57.5. And then what about the margin of error?
You can subtract 72 by 57.5.
Okay.
And that gives you 14.5.
So plus or minus 14.5.
Yeah.
Okay. Cool. Perfect. So you could have taken the high bound and subtracted that sample mean like he did. You also could have taken your sample mean and subtracted off your low bound. It still should have given you 14.5. Okay? Any questions on how to do that? That will be on the quiz, so we got to know how to do it. Okay? Do we feel like we're good? We understand it? Okay. Examples, okay, using data. So if the local news station prides itself on the high temperature being within 3 degrees of what they say it's going to be, tell which days they were successful. So I'll give you a minute, circle the days there where they were successful. They were within their margin of error, which would be plus or minus 3. Okay, what days? Monday, Tuesday, and Friday, okay? Those were all within a margin of error of plus or minus 3. So give or take 3 degrees is basically all that margin of error means, okay? Wednesday and Thursday, they were too far off, okay? 58 and 54, those are 4 degrees off, which is out of my range, okay? And 43 and 51, that is 8 degrees off, which again is too high, okay? So, any questions there? Is that just an example of how we could use margin of error in real life? Do you think most weather stations can say that they're usually within 3 degrees? Probably not, at least not around here. Okay, if a committee vote takes 55% to pass a motion, I can't talk, which of the following confidence intervals of approval rate will allow us to claim the motion will pass? Select all that are correct. Okay, so here's the deal with this. If I'm gonna make a claim, okay, I am saying that I am 100% sure that what I'm saying is going to be true. Okay? So, if I'm saying that I'm 100% certain that the motion will pass, which of these confidence intervals are going to work? So, if I look at the first one, for instance, from 51% to 56%, can I say with 100% certainty that that motion is going to pass if that's my confidence interval? No, why not? Yeah, like 51%, that's in there, right? 52%, 53%, 54%, okay? Those percentages would all make that motion fail, okay? So that's not going to work. What about B? Could I say with 100% certainty if that's my confidence interval that this motion would pass? Why? Yeah, even my lowest bound is over that 55%, so this would work, okay? Go look at the last 3. Cross them off or circle them if they're going to work or not. Is C going to work? Yeah, because even my low bound is 55, okay, which is the minimum, but it would still pass. What about D? No, my low bound's 53. That wouldn't work. And what about E? No. Okay. What about that last question there? Would any of the above allow us to claim that the motion will not pass? Which one? Why E?
Because it's gonna fail.
Yeah, it's definitely gonna fail. Okay, if I look at E here, even my highest bound is less than my 55%, right? Okay, so there's no chance within that confidence interval that that claim would pass. So, what questions do you have there? You feel okay with this? Okay. That's it for confidence intervals and margin of error. Okay, so make sure we know the difference. We know how to write each one. So margin of error is going to be plus or minus a number. Okay, confidence interval is going to be like this, parentheses, low bound, comma, high bound. We okay with that? Okay, cool. So, next thing we got, okay, and we talked about this a little bit on day 1 of this unit. It's what we call the empirical rule. Another word for this that we've heard, it's a bell curve. Okay, so we talked about symmetric distributions, and we talked about a specific type, and it was shaped like a bell. Okay, it was called a bell curve. So, bell curve, empirical rule, normal distribution, normal curve. Sometimes you might even hear it called the 68, 95, 99.7 rule. Okay, these are all synonyms. They all mean the same thing. Okay, it's all about what I'm about to look at with you right now. Okay, and here is how this works. Actually, we're going to go down and look at the picture here to explain it. Okay, so this is the bell curve, and a lot of data within our world, okay, falls within this curve. Okay, so a specific example that I'm going to talk about is ACT scores. Okay, so let's say that ACT scores follow a traditional bell curve. Okay, so what we've got here is we have the middle line here. We all see that, okay? That is going to be always our mean, which is my average, okay? So the mean is always going to go in the middle, okay? And then what we've got is each of these intervals going to the left, and then each of these intervals going to the right. Each one represents one standard deviation, okay? We talked about standard deviation a little bit on the first day. All that means is how spread out is your data, okay? So we talked about if everybody got an A on the test, okay, that would be a pretty low standard deviation because all those scores would be really close together, right? Okay, but if we had A's, B's, C's, D's, and F's on a test, those scores are going to be spread out further, meaning a greater standard deviation. Does that make sense? Yes? Okay, so ACT scores are pretty spread out, right? Okay, we can get some people that score pretty low, and then we get some people who score pretty high. So, basically how this is going to fall is 68% of your data is going to fall within one standard deviation left and one to the right. Okay, so if I split that up, because this is a symmetric curve, 34% plus 34%. Okay, that's one standard deviation left and one to the right. You with me? Okay, so then 95% of my data is going to fall within two standard deviations left and two standard deviations right. So all of these percentages, all four of them, add up to be 95, okay? The middle two are both 34, right? Because we already said those added to 68. So all that would be left to make this symmetric would be 13.5 on each side. That all adds up to be 95, okay? And then the last thing is that 3 standard deviations left and 3 to the right, 99% of 0.7% of the data falls within 3 standard deviations left and 3 to the right. Okay, so what that leaves for me, once I take out these percentages, is 2.35 and 2.35%. Okay, so that is how we read a standard bell curve. You will notice though, over here on the side, I have 0.15% on the very, very low end and on the very, very high end, okay? So these are just the rest of the data, because we can see all of my data adds up to 99.7. That's not 100%, okay? So that leaves me 0.15 on each side, and these are basically just accounting for the outliers, okay? So it's not very common to get a 36 on the ACT, okay? That would be an outlier. There's going to be maybe 1 or 2 people in the state of Missouri, I don't know, I'm making that up, that get that every time. Okay, it's not going to be very common. So that would fall within this range. Same thing for the people who just go in and maybe they leave half of it blank. Okay, or maybe they just guess C for every single question. Okay, they'd probably fall outside of the curve on the low end. Okay, because they didn't do so hot. Okay, so That would be my traditional bell curve. All of these percentages add up to be 100%. Okay? One thing though, I do want to just make sure it's engraved in our brain. Each of these intervals, let me pick a different color. Each of these intervals represents one standard deviation, right? And do you see how I have 6 standard deviations total here? I don't have more than 6. Okay, so these 0.15s on the end are not standard deviations. They're just data falling way outside. Okay, the only standard deviations I have my mean. I have 3 standard deviations left of the mean and 3 to the right. Does that make sense? Okay, I know what you're probably thinking. Do I have to memorize this? No, okay. Typically, if we spent more time on this unit, yes, I probably would make you memorize this. I've done that in the past. If you go on to take a stats class in college, or even if you go on to take it here at the high school, I believe this is something that you would probably have to memorize, but honestly, it's really easy once you start working through it, okay? And we are actually going to make one. So, going back up here, it gives me an example. It says the test scores of a class of 75 students are normally distributed with a mean of 82 and a standard deviation of 8, okay? Draw the bell curve. Well, here's the deal. All you really need is that first sentence because I'm giving you this picture right here. Okay, so basically, as long as you can work with that first sentence and draw this picture, you're going to be fine. Okay, so how we're going to do this, it's just a rough sketch. It doesn't have to be perfect. You don't need a ruler. Okay, we're going to draw a curve. Put a little number line underneath. In the middle is always, always, always the mean. Okay, it's always the mean. So in this case, what is my mean?
82.
82, perfect. Okay, and then I need 3 standard deviations left. Okay, so what I want to do, 1, 2, 3, and each of those numbers is 1 standard deviation away from 82. So first, I need to know what my standard deviation is. It is 8. Okay, so what's 82 minus 8? 74. What's 74 minus 8?
66.
And 66 minus 8?
58.
58. Perfect. Okay, now we're going to do the same thing, but we're going to go to the right. So 3 standard deviations right of the mean. What's 82 plus 8? 90. 90 plus 8?
98.
And 98 plus 8?
106.
106. Perfect. Okay, then from there, I'm just filling in my percentages. I know that this middle adds up to be 68, so each of these are 34. Once again, I'm going to give you this picture right here, so don't act like this is crazy and I'm just pulling these out from nowhere. Okay, 2 standard deviations left and right is going to give me 13.5%. Three standard deviations left and right gives me 2.35%. And then once again on the outsides of my curve, the outliers where those are, we've got 0.15% on each side. That's all we need. Okay. What questions do you have? The only other thing we got to be able to do is then answer questions about the curve that we just drew. Okay, and usually they're pretty easy. So, with the example above, how many students would you expect to score between a 90 and a 98? Okay, well, if I go up here, between 90 and 98 is what percent? 13.5%. However, it didn't ask me for a percent. It asked me how many students. So I need to multiply 13.5% times 75 students total to figure out what that is. Okay. typing a percent into your calculator, you either need to type that as a decimal, 0.135, or you need to just type 13.5 with the percent button. Don't type 13.5 times 75 because that's going to be way too big. 10.125. Okay. Question though, can we have 0.125 of a student? No. Okay. So what would we put here instead of 10.125? Yeah, 10 students. What percent of students would you expect to score below a 66? Well, let's go up here. What do we think here?
3.85. 2 point.
So below a 66 is going to be these two percentages, right? Can't we just add those up? 0.15 plus 2.35? What would that be? 2.5. There you go. And we can leave it as a percent because it didn't ask me for students, it just asked me for percent. Okay. Cool. One hypothetical thing, okay? Let's say, for instance, that on this first question here, what if that answer would have been like 10.9? Could I have 0.9 of a student? Can I round up with that, you think? Can you round up people? Okay, so that's the one thing about statistics that a lot of people have trouble wrapping their mind around is when we're dealing with anything with a heartbeat, basically, so people, animals, whatever, you always have to round down, okay? You can't round up. But if you're dealing with something else like temperatures or whatever, you feel free to round up, okay? But just know that anything with a heartbeat, you got to round down. Does that make sense? Okay. All right. I'm going to give you a couple minutes. I'm going to put that curve back up here, but I want you to go and draw this scenario, a bell curve representing this scenario. I'll give you like 2 minutes or so. You actually have the picture in your notes, so I'll just let you use that one. Okay, so use that picture. You will have that on the quiz, okay? But go and take a look at that. Okay, so once again, it's a rough sketch, so it doesn't need to be professional by any means. But you should have put your mean in the middle, 3 standard deviations left, 3 to the right, and we should have labeled our percentages. So I'm going to quickly label the percentages first, just because that's the same for all of them. Handwriting is not the best today, but it will work. Okay, so there we have it. There are my percentages. And then I need to put my actual numbers in there. So my mean goes in the middle. What is that? 82. And give me the standard deviations going left of 82. What's going to be the first standard deviation to the left of 82? 76. And then what? 70 and then 64. Perfect. And then to the right of 82. 88. 94. 100. Perfection. There we have it. Okay? If you wanted to take this just a little bit further, okay, and maybe you wanted to make sure you had your 68 here in the middle, okay, and then maybe you wanted your 95 here for the other two. You don't have to do this part, okay, but just if it helps you to visualize a little bit better. Okay, and then 3 standard deviations gives me that 99.7, okay? If that helps you, great. If it doesn't, you don't have to do it, okay? You can always just add up the percentages that we wrote on the inside, okay? But once again, just know 1 standard deviation left and right adds to 68. 2 left and right should all add to 95. and then 3 left and right should add to 99.7. Does that make sense? We all understand this? Is it clicking? Is the rain just bringing down our mood a little bit today? You guys seem sad. Are we sad? Don't be sad, be happy. What? The first day back from spring break, and I'm giving you a quiz. Does that make me a mean teacher a little bit? It's free retakes, right? Yeah. Okay. Okay, so here's the deal. Lots of questions here, but these are very good questions because they're just like the ones that are going to be on your quiz. Okay, so one thing I want to point out though, if it is asking you for an interval, so for instance here, we'll do this one together. What interval contains the middle 68%? Well, tell me, what interval, okay? That's within 76 to 88, perfect, okay? Write it like it was a confidence interval, okay? So just in parentheses, you would write 76 to 88. Okay, so that's how we write intervals. And the rest should be pretty straightforward. So I'll give you a couple minutes. I want you to answer those questions. Feel free to work with the people around you. And I'll be walking around, so ask me anything you got. Okay, what interval shows the scores of almost all the students? What do we think?
64 to 100.
You got it, 64 to 100. Okay, we can't go any more standard deviations left or right. Okay, so 64 to 100, that accounts for 99.7% of the data, which I'd venture to say is almost all the students, wouldn't we think? Yep, okay. What percentage of students scored above an 88?
16%.
16%?
Yeah.
Okay, so how'd you find that?
Added 13.5 to 2.35 and 0.15.
Yep, and that gave you 16%. Perfection. Perfection. Okay. So just adding everything to the right of 88. All of those percentages, good. Any questions there? All got that? Okay, what percentage of students scored between 70 and 89? Sorry, 70 and 88?
81. I got 81.5.
81.5. Good. Okay, how we did that was just looking between 70 and 88. Okay, adding up all of those percentages. So 13.5 plus 34 plus 34 should have added to 81.5. Okay, we feel good about that? What about what percentage of students scored less than a 62? Or sorry, that should have been 64. That's a typo. Sorry. Yep, it'd be 0.15 though. It'd be 0.15. Okay. How many students scored below an 82? 250. Okay, how we find that? Okay, well, first off, we need to know what percentage would be below 82. So we could just add up everything to the left of 82, right? Okay, which ends up being half the curve. We know this is symmetric because it's a bell curve, so 50%. And how many total students do I have? 500. So 50% of 500 gives me 250 students. So that's where we got that. Okay, and then how many students scored between 82 and 94?
I had 237.
237. Okay, perfect. So between 82 and 94, we add up those percentages, okay, just like we did for number 7. So I'm going to add 34 plus, what was it, 13.5%. And that's going to give me 47.5%. And I multiply that by my total, which we said was 500. And then I'm going to get a decimal, right? 237 and some change. But we're talking about students. Can we have point something of a student? No. So that's why we just keep it 237. So 237 students. Any questions on that? So 47.5% times 500 is how we got that. How many students scored above 70? So add up all those percents. What do those all add up to be? Do we see where 70 is? And we're just adding up all the percents that are above it. What is that? Try again.
47.
What'd you say? 63.4. I think it should be higher. We're adding up all the percentages that are above 70.
Yeah.
So 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15.
Yeah.
97.5. There we go. Oh, that's not what you said. I thought you said 47. That's what I heard. 97.5 times
500
equals
487.
487. Okay. Sorry.
Is that not what I said?
I was asking for the percentage
Oh.
first because we were doing the process. Sorry. I misunderstood you. But yes, it's 487 point something. Do not round it up. Round it down. Sorry. What questions do you have there? Okay, and then 10 and 11. Okay, multiple answers could be right on this, but what would it mean in regards to this scenario if the standard deviation was a 2 instead of a 6? Well, let's go back to what is standard deviation again. What does that mean? Yep.
I was just going to answer the question.
Yeah, go for it.
That the class on average would receive a closer score to 82.
Okay, perfect. Okay, so the class would be closer to 82. Their scores would be closer. Yep, that's perfect. That's exactly what we want. So remember, standard deviation is how spread out your data is. So if you're going to have a standard deviation of 2 instead of 6, the scores are all going to be closer together and closer to your mean, which Noah said was 82. Love it. So then going the opposite direction, if I made the standard deviation 8 instead of 6, what would that mean?
Scores are very more.
Yeah, the scores are going to be more varied. Scores are more spread out around your mean. Got some high scores, we got some low scores, okay? What questions do you have? We feeling all right with this? Not too shabby? Okay, let's take some time, review this, review it with a friend, and then we will do our activity.